Good morning, my YouTube viewers. It is Crystal here. I'm just here because I wanted to give you another code review. And basically, the reason why I'm giving you this code review is because I won a bronze medal on it. The last code review that I gave you, I talked about the Jack's Linreg cliff edges, and I got a 77406 on it. And then what I decided to do was I decided to go through and take out that code where you deleted or you dropped the columns that had a high correlation. And when I took that out, that piece of code, and used all of the columns, I got a 77468. So my accuracy just slightly improved on that. And then basically, but what I won the bronze medal on, and that's my 39th bronze medal, by the way, was the linear regression min-max. And I suppose the people in Kaggle liked that algorithm better than they liked the cliff edges algorithm. And because of that, I decided that I would go ahead and make a code review on this algorithm because I got a bronze medal on it. So we'll come over here. And you can see here I've got a bronze medal. My accuracy was 77406. And it's very similar to the last code review that I did, with the exception that I used the min-max instead of clipping. And I'm supposed that Kaggle liked that better. So I'm going to do a code review on that. So I created this program in Kaggle's Jupyter Notebook, which is free, and I saved it in my account. But what I'm going to do is I'm going to give you a link to the notebook so you can look at the notebook if you want to, and you can study it. So after we have created the Jupyter Notebook in Kaggle, we're going to start with our problem statement. And the problem statement is predict the probability of binary software defects. Now, the thing that I did was I used JAX. I didn't use sklearn. Now, if you use sklearn, then what would happen is you would have the ability to use print proba in their logistic regression, and the print proba will tell you what the probability is. But I'm not using sklearn, I'm using JAX. And JAX doesn't have a print proba. I actually tried to find code for print proba so I could use the print proba code, but I couldn't find the code. And I was looking on Stack Overflow, and somebody on Stack Overflow said that this is a regression problem. So even though it's a binary classification, in order to get the probabilities, then you need to use linear regression. So after I have created the Jupyter Notebook and done the problem statement, we're going to import the libraries. So the libraries we're using in this instance is pandas to convert the data set into a data frame, OS to go into the operating system and get the CSV files that are going to be converted to data frames. We're going to use sklearn's train test split to split the X and Y variables into training and validation sets. We're going to import JAX, and JAX is going to be very similar to NumPy. So you've got import jax.numpy as JMP. JAX is similar to NumPy, but it's different. So one thing that's different about JAX is the fact that its arrays are immutable. And because its arrays are immutable, you can't change the value in the array. So you have to work around that. And there are ways that you can work around that. So whenever we did the min-max, I couldn't use the code the way that I normally would use it. I had to work around that, and I will show you how I worked around that. We're going to import random so we can create a random number generator. We're going to import Matplotlib to visualize the data, and we're also going to import Seaborn, which enables us to statistically visualize the data. So after we have imported our libraries, what we're going to do is we're going to use OS to go into the operating system and retrieve the files. And the three CSV files that we had are train test and sample submission. So after we retrieve these files, what we're going to do is we're going to use pandas to take the CSV files and convert them into data frames. So we converted them into data frames. And then what we want to do is we want to view the data frames, but we want to see all of the data frames. So we do pd.setOption display.maxColumns and then none. And that enables you to display all of the data frames. So we're looking at the train data frame now, and you can see that the train data frame is either a float or an integer, but the defects is going to be true or false. So that means you're going to have to convert the true or false into an integer because the defects are Boolean. And see, it says right here in train info that the defects are Boolean. So we don't have any missing values, fortunately, so that means we don't have anything to impute. Now we check test. Test has the same format that train has, except for the fact that it does not have a defects column. There are no missing values in test, so that's good. We don't have anything to impute. Now we're going to check submission, and submission has your ID and then your defects, and your defects are going to be a probability. We're going to drop the ID. You don't need the ID, and the reason why is because in pandas, every row is automatically indexed anyway. We're going to analyze the label. The defects is your label. And we're going to convert the label to an integer with train defects equals train defects dot as type integer. And so that changes it from a Boolean to an integer. So that's the format that the computer can use. So we're going to use Seaborn to create a histogram of the label. And you see most of them are 0 and a few of them are 1. Unfortunately, I don't know enough to be able to balance the data set in JAX. But what I can do is I can study how to balance the data set in JAX, and then maybe work on improving the code. Now we're going to define our dependent and independent variables. So y is train pop defects, and x is train because when you pop the defects, that means it's no longer in the data frame. And x test is test. We're going to build a heat map of x. So you see we've got our heat map of x, and you see you have a lot of columns that have a high correlation. So what I did was I deleted all of the columns that had a high correlation, which was total ops, total, 0p, nd, and branch count. But if I hadn't deleted the columns that had a high correlation, then I probably would have had a better score. So the next time I run this up, I'm probably going to take out the columns that have a high correlation and see if that improves my score, because it certainly improved my score on the previous data program or Jupyter Notebook. Now what you have to do is you're going to have to convert the data set into JAX arrays. So y equals jmp.array y, x equals jmp.array x, x test equals jmp.array x test. So now these are JAX NumPy arrays. Then we're going to use sklearn's train test split to split the data set into training and validation sets. Now we're going to define a linear regression model using JAX. So we've defined our normal equation for linear regression, and then we've defined the predict. So the linear regression model is an easy regression model to use, and that's why the first models that people, it's one of the first models that people learn when they're learning machine learning and data science. And we're going to take the, we're going to use JIT, that's just in time, to convert the normal equation to JIT. And so what that does is that speeds it up. And then now what we're going to do is we're going to put the data into the model. Beta equals JIT LR, X train, Y predictions equals predictions, X val beta, and then we're going to print the predictions. So you printed the predictions. We wanted to find out the time it takes for JIT to work, or JIT LR to work, and it's 44.72 milliseconds. And so it worked much more quickly than if you didn't have JIT. And the thing is that although this is a small-ish project, if you had a really big data set with lots and lots of data, that extra training time would make a big difference. And you can also put JIT on predict, because on my previous Jupyter Notebook that I did on this, I think I did put JIT on predict, and that speeded up the prediction as well, but I didn't put it on this one, which I could have done, but I'm just doing this code review because I got a bronze medal on it. We're going to calculate the RMSE, that's root mean squared error, and your RMSE is 0.38, so that's not too bad. And now what we're going to do is we're going to use Matplotlib to visualize the actual values against the predicted values. So you can see there's your actual values and there's your predictions. The predictions is the dashed line as well, and the actual values are the blue dots. Now we're going to predict on the test set, and so predictions equals predict x test beta. Then we're going to print our predictions. And now what we're going to do is we're going to define our minimum and our maximum. So what we're going to do is we're going to normalize the predictions. And as I said at the beginning of this video, that JAX arrays are immutable. And because they're immutable, you just can't change it. So you have to change the way you work with the data a little bit. So min equals predictions.min, max equals predictions.max, predictions equals predictions minus min over max minus min, and that gives you your prediction. And obviously that is what Kaggle liked, because that's why I got the bronze medal for it. So I thought, oh well, I'll show you what I did. You can do it differently if it's NumPy, but because JAX arrays are immutable, that's the only way that I know of that you can do this on JAX. So now what we do is we use C1 to visualize the predictions, and you can see that the predictions are generally between 0.3 and 0.4, but you have a few that go all the way to 1 and a few that go all the way down to 0. We prepare our submission, and by taking the predictions and putting them in the defects column of submission, and you can see that there are your defects. That is the probability that the defects is going to be 0. So when I submitted my work to Kaggle, I got a 0.77406 or something like that. And so the highest probability was 0.79. So my score was only 2 points less than the highest score. So that wasn't too bad. And obviously there are things that I can do to improve the score, such as take out the code where you remove the columns of data that have a high correlation, because I know that that will improve my score. And also maybe if I learn how to balance the data in JAX, that might improve my score as well. So that's it. That's it for this code review. I decided to give you the code review because I got a bronze medal on it. Kaggle obviously liked it, or they wouldn't have given me a bronze medal. So I'm going to go ahead and conclude this video because I've talked about everything that I need to talk about in this code review. But I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you so much for watching my video. I look forward to making more code reviews for you in the future.